Okay, welcome to a new topic, Unit 4, and this topic will be called Science Fair that you'll be studying. It'll basically take the course of 8 weeks, okay, so roughly 4 lessons a week. This will be after your cells topic. Okay, this will run halfway through Term 2 and into Term 3. So let me just first give a bit of an introduction. Now, science is fascinating, right? Well, to me it is anyway. It encourages us to question and think about how the world works, right? And it shows us what we know know now, and it helps us to improve for the future. So in this topic, you'll be learning about how scientific investigations work, okay, how experiments work, and you'll be investigating plants. Okay, you're studying plants and how they work. And I'm not really sure about there's a mandatory stage 4 science student research project that you have to do. I'm not sure about that in terms of what will be happening because of the coronavirus, as you know. But we'll see. Let me start off by talking about scientific research. Okay, scientific research. What is scientific research? Okay, basically it's a series of experiments that tests various hypotheses relating to a problem, right? So it's a series of experiments testing various hypotheses. I'll talk about hypotheses later. These are guesses, right? So guesses that you make before you do an experiment relating to a problem. So they're experiments that you do to work out what the solution to a problem is. And scientists carry out many experiments, okay, for one topic. They often do it using a team, right? Examples include at a university. Okay, so scientists carry out many experiments for one topic, and it's often done by a team. Okay, so in my case, before I got into teaching, I was working at a university as a research scientist, and I was part of a research group that focused on developing a type of, or studying a type of diamond, okay, using a laser. And each group member had a different task to do, but we were all working on the same thing pretty much, okay, the same topic. Okay, so for example, at a uni, okay, the most common place where you find scientific research going on. Now, research, don't know if you already know this, but research can take a long time, okay, to do, okay, because experiments don't always give the results that you want. They don't always give the results the first time, right? So again, in my case, there were many experiments where I had to repeat, okay, because the results were absolute rubbish. That's not necessarily a bad thing in science. It's actually a good thing because it shows that you know what you're doing. Okay, and my research, for example, so a research project can take, in my case, when I was doing my master's, took around 10 months to do the experiment and to write about it. Okay, the scientific investigation took about 10 months, which isn't really much compared to the other projects, which might take 3 years or more. Okay. It can take even many years, so it can take many years to do one experiment, okay, to make a discovery. Okay, and many discoveries actually occur by chance. I don't know if you already know this. Here's what you need. Okay, you need patience. You need hard work. And you need creativity. Okay, scientists are actually creative people. Particularly people like me who are physicists by training. Okay, we're very creative. We can come up with things in terms of designing experiments, what we can use. Patience, you've got to be patient, right? Things don't happen overnight. Most of the time, and you have to be a hard worker. Okay, that's what you need. And you also need passion. You need to love what you do. So how does an experiment work? Okay, normally it starts with an observation. Okay, so you make an observation. Observation is a fact. Okay, observation can be qualitative. So you've got to know this word, qualitative, quality. I think these are written down in your notes, written down in words actually. You've got two types of observation, qualitative and you've got quantitative observations. Okay, these are measured and they're stated as numbers. Give an example. For example, the temperature of an ice cube is minus 2 degrees Celsius, okay? That's a quantitative statement. So example, temperature, temp of ice cube is minus 2 degrees Celsius. That's a quantitative statement. Quantity, think of numbers. Okay, a quantity of the quantity of apples in a kilo. Okay, that's 5. Let's say 5 apples in a kilo. Qualitative, for example, a qualitative statement is the color of the chemical is blue. Okay, that's a qualitative statement. That's a fact. Okay, in words, no numbers here. So how do scientists actually observe stuff? Okay, we use our 5 senses, of course. Okay, we use our 5 senses. Okay, from memory, they were touch, sight, taste, touch, sight, taste. I forgot what the other ones were. Okay, there are your senses. Hearing as well. There's one more. Touch, sight, taste. Here, okay, doesn't matter. Okay, we use our 5 senses to make observations, right? You got to use yourself, okay? And we got to use these senses to record data accurately, right? Now we should also check good scientists. Okay, they have to check their observations. Okay, a number of times. It could be 2 times, it could be 10 times. Number of times to make sure there are no errors. This is very important. If there are errors in your work, people will pick up on it. It's not a good thing. So recording and reporting of results, okay, allows other scientists to repeat and for you to repeat your work. Okay, because if you don't write it down, if you don't write your experiment down, you might forget how to do it the next time around, or other scientists need to know how to do it as well to make sure that it's correct. So in my case, for example, I wrote a thesis, I wrote a big report. It was about 70 pages long with steps, with what materials I used and what I saw, okay? So that's what a scientific investigation is all about.